In the previous video, we talked about the classification of ligands on the basis of charge on them. In this video, we will be talking about the classification of the ligands on the basis of number of donor atoms. Dear students, the number of donor atoms in the ligands is called as its denticity. Denticity. Alright? So, denticity stands for the number of donor atoms a ligand contains. So, on the basis of the denticity or the number of donor atoms, the ligands can be of 7 types. Alright? 7 types. So, let's see them one by one. The first kind of ligands are known as unidentate ligand or monodentate ligands. As their name suggests, such ligands contain only one donor atom. Like in case of H2O, it contains oxygen as a donor atom. Second example is amine. Amine, I hope you remember. Amine is the name as ligand of NH3 molecule. Here, nitrogen is the donor atom. In case of OH minus, hydroxido as ligand. Oxygen is the donor atom, and like this, many more examples fall in this category. Now, the second is didentate ligands. As the name suggests, didentate ligands means they contain 2 donor atoms, like CO minus single bond CO minus. Generally, this ion is known as oxalate. But when this oxalate ion is used as a didentate ligand, it will be known as oxalato. In short, we can write it as OX. The second example, which I have written here, is glycinate ion in general. NH2CH2CO minus in general is known as glycinate ion. But when it is used as ligand, it is known as glycino. In short, we can write it as GLY. Third example, which I have written here, is ethylene diamine is its name in general as well as ligand. In short, we can write it as EN. In all these 3 examples, if you look carefully, like in case of oxalato, it has 2 donor atoms, this negatively charged oxygen and this negatively charged oxygen. So, oxalato becomes a didentate ligand. In case of glycino, 2 donor atoms it has. One is nitrogen, which carries a lone pair, and other one, the negatively charged carrying this oxygen. In case of ethylene diamine, which is also written as EN, has 2 donor atoms in terms of the nitrogen atoms as amino group. Now, both of them, they carry lone pair. So, they act as 2 different donor atoms for the same ligand. So, all these are the example of didentate ligands. Alright. Now, next classification or the third way of the same classification is tridentate ligands. Tridentate ligand means the kind of ligands in which one ligand will have 3 donor atoms. The best example to understand is diethylene triamine. Diethylene, one is this and one is this. So, diethylene triamine. In this diethylene triamine, it has 3 donor atoms, and all 3 donor atoms are nitrogen atoms as amino group. Here NH2 carries lone pair, here NH carries lone pair, here NH2N carries lone pair. So, diethylene triamine is a tridentate ligand. In short, in place of writing a big name, in short, diethylene triamine can be written as DIEN. Now we have next tetradentate ligand. Tetradentate ligand, definitely you must have understood. It will be having 4 donor atoms in one ligand. The best example of this is triethylene tetramine. Triethylene 1, 2 and 3. Triethylene tetramine, 4 amino groups, 1, 2, 3, 4. So the name of the compound is triethylene tetramine, which in short can be written as TRIEN. This triethylene tetramine one ligand molecule has got 4 donor atoms and 4 nitrogen atoms in 4 amino groups present in the molecule. 1, 2, 3, 4. Next we have pentadentate. So pentadentate means this one ligand will have 5 donor atoms. The best example for this is ethylene diamine triacetato. So you can look at the structure of the compound, ion, CH2CO minus, NH, CH2CH2N bonded with CH2CO minus, CH2CO minus. Here in this particular ion, total 5 donor atoms are there. 3 negatively charged oxygen, alright, plus 2 nitrogen atoms as amino group, 1 and 2. So total 5 donor atoms, 1, 2, 3, 4 and 5. So ethylene diamine triacetato is pentadentate ligand. Next we have hexadentate ligand. As the name suggests, one ligand will be having 6 donor atoms in it. And the very beautiful example for this is ethylene diamine tetraacetato, which is also known as, or in short can be written as EDTA. Ethylene diamine tetraacetato. So this is the structure of the ligand. So you can count here, it has 6 donor atoms, 4 negatively charged oxygen, 1, 2, 3, 4 and 2 lone pair carrying nitrogen atoms in the form of amino group, 1 here and 1 here. So these are 6. You must be thinking that I told you that 7. The 7th one is known as bridging ligand. Bridging ligand. So my dear students, bridging ligands are such monodentate ligands which can simultaneously attach themselves to more than one metal ion. Once again I'll repeat. Bridging ligands are actually monodentate ligands, but they are such monodentate ligands which can simultaneously attach themselves to more than one metal ion. Clear? I have written here few examples of such bridging ligands. Here OH minus, NH2 minus, NO2 minus, Cl minus and many more are there. So these were 6 ligands on the basis of their denticity. Apart from this, one more way is there to name a ligand, name the ligands. There are some specific kind of ligands which are known as chelating ligands. Chelating ligands are those ligands which when bonded, chelating ligands are those ligands which when bonded to a central metal atom can give rise to 4 or 5 membered ring-like structure. So here this is one example. I am going to hide its other side. The central metal atom, ion. To this central metal ion, this is one ligand. Actually, it is a didentate ligand. It is ethylene diamine. When ethylene diamine gets bonded with the copper ion, so one ligand itself is capable of forming 2 coordinate bond. In doing so, it is giving rise to a 5-membered ring-like structure. You can see here 1, 2, 3, 4, 5. Same way other side. Other side also it is bonded with the ethylene diamine. So this ethylene diamine is also giving rise to 1, 2, 3, 4, 5-membered ring-like structure. So my dear students, such ligands which when bonded with central metal atom or ion give rise to 4 or 5-membered ring-like structure are known as chelating ligands. This phenomena is known as chelation, and such coordinate compounds or such rings thus formed in coordinate compounds are called as chelates.